Hello, I am Meet and welcome to another video. In this video, we'll be seeing how to build, run and deploy cloud functions on local system as well as on Appwrite Cloud using the Golang runtime. If you don't know what Appwrite is open source backend as a service, which is similar in some sense to Supabase and Firebase. It has services, backend services like cloud functions, databases, storage, authentication, messages and a whole bunch of other things. In this video specifically I want to demonstrate what are the different ways of deploying cloud functions on Appwrite Cloud leveraging the Golang runtime. So first we'll see how to install the Appwrite CLI, and for that I'll just take in the command from the documentation and paste it in here. You can grab the binary, which I am doing it with the CLI command, or you can just install it with npm. So it will install the binary and give us the Appwrite binary so that we can use it from the command line. So once we have given the permissions to run the file, that is Appwrite as a command into the CLI, it will give us all the available information that we have. And you can see the version, it is 6.2.2, the latest version which is there on the community version. Appwrite login. So we need to log in into the Appwrite server, that is the Appwrite cloud instance, and just enter the email and password, and that should be good enough. You can go into the website and create an account for that if you don't already have one. You can see Appwrite who am I, which will show us which is the user we are currently logged in. And now we can create a project using the Appwrite init project function. Appwrite init uh, Appwrite init project will be the command that we use to create a new project. So with this we can provide a few fields like the name of the project, the organization that we are belonging. I just one organization, and then provide the name. I just provide a random dummy name here. So this you can tweak later on. And ID we can keep it optional. It will be a unique generated from Appwrite in Appwrite itself. And so this way we will have created the function on the server as well as on the local instance of it. So if you see in the dashboard, so let me go into appwrite.io. I'll just need to log in into this instance, into the server. So I'll provide the same credentials that I used it previously. And then if you would see here, we will have created a hello world project here. I have a few other projects which I have created previously, but hello world is the first project that I've created using CLI right now. Create the project on the like cloud, Appwrite cloud, as well as on the local instance of this. The local instance is not a project, but it's just a configuration for having the Appwrite.json file. And you can see the functions. We are not creating any functions, so let's start by creating the function with Appwrite init, and it will know that we need to create this function. So we provide the name of the function, and we can just give it a name, and so this will be a random unique ID for the function. And then we need to select the runtime, which I will be selecting as Go, and the specification for the compute to use, that is how much RAM or like storage you want to use. So that is default for a free tier. And then Appwrite run function. So we will have a list of functions that we can run. So we just only have one function in this project, so we'll run this greet function, and this should pull up the Docker image for that specific runtime and create that image out of that function and run the container. So it will install the dependencies that it will have and sort of build that image and run the image, and we will have the container running on the local system. So you can see the function is created and we can view it live on localhost port 3000. So if I go to another instance of a terminal and do a quick curl, so curl localhost just to ping the server. So localhost 3000 is the port. So let's do that, and this should give out the default response which is there in the function. This is a templated function, so this will have all the things that it was configured to serve. And if you would see the like the structure of this project, we have appwrite.json which will have the configuration for that project level things, and functions have a separate directory called functions, and slash greet slash main.go is the entry point for this greet function. And there are few things here, the boilerplate code. In the main function we have the response context and things that we do with the response and request objects. So with that, let's explore the the main entry point for this function. So here we have this main.go in the greet function, which has this response that we saw, right? And this has this response structure. Inside the main function, we have this accessible things that are there using the context providers. They are using open runtimes is a package which is standardized way of using request and response for cloud functions maybe. So those are being used, and if you want to run this function we can just use this that we used earlier, right? So that is how it is able to get the response that we saw earlier, which was giving a response structure from the cloud function. And now we also have slash ping as we saw in the code. Now it responds with pong, right? So that was the expected behavior from this function. So you see the if the path is slash ping, then it will return with the pong response. Now let's try to do a few things with this. You would see the the default function route is slash. So it has started the server, and now let's do it again. So view that, and now you can see that it has responded with this specific function, that specific response that you have generated, and this response is of type response that is defined in the above struct. So that is the boilerplate, the basic functions provided by Appwrite. If we push, so right now the Appwrite cloud instance of this project is not, it doesn't have any functions, because functions are first created locally and we have to push the functions into the cloud instance of it. It is served locally right now, so we need to push this, and we can select the function that we want to push, and this should build the image and push it. Sorry, it will push the function specification first and then build and deploy it on the cloud instance of the project, which is Appwrite Cloud. So once it has built and successfully deployed, we would see that function. Now we can see that there is one function being listed in the console of Appwrite projects. So here this function is deployed successfully and it is active, and you would see the endpoint, which is this cloud function URL that we can use to execute the specific function. And let's do this same thing for that specific URL. So if we just hit this endpoint, we should get pong, but it didn't give out any response. That is weird. Let's see the deployments, and let's go into the domain, like the slash route. Okay, it's still not giving the result. Maybe there's some issue here. Let's run this. Okay, that gives the response as expected. So what is the issue here? Oh, it is HTTPS. Okay, yeah, that is the issue. Like it was using the HTTP version, not the secure version of it, so it might be the issue. And if you see, that is working out expected, and the ping endpoint also gives out the pong response. Okay, so this is the basic function that we deployed. This was just a templated function that we deployed via CLI, right? Because we had this function created locally and then pushed this change, this function into the cloud instance of Appwrite. So these are the way we can interact with the function execution and deployments using the console, right? And now let's try to modify what we can do with this boilerplate code, right? So this is a main function, right? And so this has created this main.go, which is the entry point for this greet function, and we have imported a few things which it has already imported. So here this is client, this is a Appwrite client that is used to access the the uh, Appwrite project instances. That could be the storage, the database, the functions, etc. So we can use the Appwrite function, like not Appwrite function but Appwrite function API endpoint or project ID to get the instance of that client. So in the so what this function is doing is just list of users that will be there in the default, like the boilerplate in the default project that will have users. So this is just listing out the users that are there in this project. There are none right now, so it is returning empty right now. So it is logging out those, not returning anything in the function in the output of it. So once that is done, let's explore a few things that we can do here. So we can get the body, like from, let's say you are sending a post request, not a get request in the function. So we can get context.request.body JSON, and so this is open runtimes package that is Appwrite is internally using to like interact and work with request and response kind of objects. They have not used their own like abstraction top of request HTTP layer. That is a good thing. So body JSON will just take in the request body and load it into a variable that we can provide it. So this will be using like a unmarshal kind of thing to get the uh, like to deserialize the JSON object into a Golang specific structure that we can use now into the function and then pass it on to any other logic that we want to do here. So there are a few more things here, like the headers, the method that is sent from the request, and then we can get the query params as well. So we can get the query or query params, query string, sorry. So query will be a key value pair or a map of string with string, and query will be a list, just a string, right? So you can do it yourself as well. So in this case, let's say the request path is /user and we want to just render out the like username and the post which is sent from the request body. So we'll just create a user response structure and have the user and the post as the fields, and then you like send this exact thing into the response. So this open runtimes has this response JSON here that we can send that like as a JSON type of request, the type of response. You can also send like binary or text field into the things to render out HTML or just file data into the response object. So we can send the response. If there's an error in unmarshalling the body, the request body, then we error out and just return the default response that it was already sending. So now this is up and running. We can now run this function locally. So we have made changes in the greet function. So here we are directly accessing the body. So I just made it into the post request so that we can only unmarshal the body when the method is actually a post request and not when the method is get request. So that will only trigger it when the method is post and the route is like the /user endpoint is added. So that will have only been populated when the method is post. it is initialized as empty interface, so that should not be an issue. Okay, so this will fix that issue. So let's now um, run this function locally. So Appwrite function, sorry, Appwrite run function, run functions. So this will give us the things that we want, and once that is running, once that is completed the building of the function, then we can hit this localhost 3000 port, and let's do a call localhost 3000. Let's see if this default works. So this will be as usual, and now let's add the query parameters that we just logged it into the server. So key equals value, and you would see that now we have the query string, which will be just a single string, as it is passed from question mark till the end of the URL. However, the query will be a key value pair or a map of string with string. So key is the key and value is the value. So you can see that we add more keys. So let's say key is ABC and the value is DEF. So this will be passed key as ABC and DEF as the value. So there are two ways that you can use. If you want to parse the query yourself, you can do that, or it is already parsed with the query uh, object in the context.request structure. So we saw query parameters with the get request. Now let's see how we can use the post request to get to to see how it works there. So for slash user, it will error out because we are trying to marshal the body and get out the username and post, which is not there. So let's hit a post request with the data or with the JSON with the username as the key. First will be the username as the key, and then let's provide the key. And the value will be sorry, the next key will be post, and we'll see that. Now we need to restart the server, sorry, restart the function. So it will rebuild the function which has errored out. So now we hit this again once this gets live. Okay, so now it's live, and now let's hit this. So we should see that the body is now populated as post and username as the fields, and we are able to get the query parameter as well, but the path is slash user. That is what we have logged it here, and if the path is user, we get the username and post and return the user response into the object, and you are able to see that the response is indeed the thing that we sent there. So that is cool, that is working what we have designed it for. So we are able to get a few things from the request and send the response as we want. So these are the few things, basic things that we can do on top of functions, for like basic functions that we can run in the Netlify, sorry, not Netlify, in the Appwrite cloud. So this was a default function, right? And now we want to push this new changes the function, which was greet function. Now let's push the latest changes that we added into the Appwrite cloud. So you would see this gets built on the server itself, right? So this first build will be active and the second one will be building. So you would see that this is indeed building there as well. So this doesn't build, so when you do push, it doesn't build it on your local machine, it does it, and so it takes the configuration and deploys it onto the Appwrite cloud or wherever you have hosted the Appwrite instance, and deploys the function there. So once that is deployed, now this is the latest deployment is active, so we can change, we can check the latest changes that we did. So we already, the URL endpoint will be the same for this function, we just need to check the response. So for the default get request, it was the same as usual. We didn't tweak anything. However, for post request, that was changed. So let's do a post request to this same endpoint with the data as a JSON with the fields username and post. So we need to send the slash user path, not on the default path. So let's add the username as the key and the value meet, and the field, the other field is post, which we can set the value anything we want. And yeah, so once we hit this, yeah, it is able to return the thing that we have set, right? So this is now deployed and working as expected. So if you see the logs, we are now able to see a lot of things in there. The body is not thing because this is a kind of secure way to log those out, but you can see in the context in the logs that we are set, we can see the logs. The query is empty. The query string will be also empty because there's nothing in the query parameters that we have set. So that is the things that we have added in the logs. Headers will be that, and body is hidden for security reasons. Demonstrate this further and try to get the query parameters here as well, with the query as, let's say, hello. Let me add the quotes around the URL, and if you would see that we have just hit this endpoint, and the executions list should have this logged out, and you can see the query is the key value pair that we stored, and the query string is the actual query that we have sent. So far, so this is so good. So we have seen how we can, so we created a function, we deployed the function, and then we made some changes locally, and then deployed the same changes to the cloud instance of this function. So that is working fine. Now we can do a few more things, like with the functions that list deployments, create deployment, or list executions as well, that we saw in the console as well. But that's not that's not what I want to show. I want to show that Appwrite.json is a configuration that the Appwrite CLI uses in order to understand what to push and which changes to push to the cloud instance. So this is all configurable. So now I want to create a function from the console. So let's create a function. Let's name it what naming is hard. So let's call it greet. No, greet 2. No, that's one. So let's call it namer. I will be using some package to generate random names, random 2-letter name and verb, or whatever you want to call it, that Docker container has, right? So we'll set this up. So we can provide the parameters here, and we want to set it public and execute all. But for now, we just create the function and connect later wherever you want to connect to a GitHub repository or existing repository. We'll do that later on, but we just want to create the function right now. So we have this ID, right? The function ID that we can use on the apply.json to populate it with the latest changes. You can do that here, like you can edit the apply.json to like add a function, but that's not a, like a correct way to do this. Like if you see apply.json is populated by the CLI, so you should not be ideally tampering with this file. You can like add this dictionary, right, with the ID that you grab from the console and populate it accordingly, but that's not how it works. That's not how it should be working. Like we can do that, but the ideal way to push and pull changes is using the CLI. So we'll stick to that and use Appwrite pull to fetch the changes from the console. to your local environment. So we saw push, now we saw pull. So we'll pull the namer function that we created. So it is able to detect that, and we'll be want to pull the source code of the latest deployment. Yes, we want to do that, and this will create a directory with inside of the functions called the name of the function. There is namer, and this will have the usual structure that we have with the templated cloud function from Appwrite. So Appwrite has this standard template. So inside of functions slash namer slash main.go, this is the usual template that we saw earlier. Now I don't want any of this. I can uh, just let's get the things that I want to use. Now I want to demonstrate how we can use the like, any third-party libraries that we can grab with uh, inside of this function. So I have one uh, library that we can use, but just a random experiment to demonstrate we can use third-party libraries into Appwrite functions, which is a Mobi project, which is a Docker thing, and you can see there's a name generator that it comes with. So this is how it generates like the random container names for Docker. So let's explore this and just try to create a function out of it. So go get this module. So it is mobi slash mobi. This will fetch the package that we want. Oops. Oh, sorry. I need to be inside of the function function package. So it's not a not a package. So I want to go into function slash namer and then go get that function that package. So once we have that package, now let's try to tweak the actual function. So function slash namer slash wo.mod will be populated. So now we have this dependency installed, and once that is done, this is a normal flow with how you create and manage normal Go packages. It's just that there is a convention to write the function. So we'll grab this mobi uh, package and use this name generator module to sort of get the functionalities that we want inside of this. So let's parse the nums. So what the general idea of this is to, let's say, return a random name. However, we can provide how many names we are going to generate using the query parameters. So if the user has provided a n, like question mark n is equal to something number, then we need to generate that many random names. So we get the string from the query params, so that n will be a string, not an integer directly. So we need to convert using strconv.atoi. This will take in the string and convert into integer. If there is an error, we just keep the default like number as 1, so it doesn't messes that up. Right? If there's no error, we just parse integer and then create a nums, like a list of strings that we want to return. It will be the randomly generated names. So we iterate over all the names, the count, that is how many times you want to generate the name, and then populate the num generator dot get random name. So this is a function that will actually return the random name, which is like a combination of adjective and surname. So that is what it does, and we can retry it if you want to have collisions. So we can skip that. We just pass it 0 there, and then return the response as response.json and names. So name is like a list of strings, so it can be marshaled into a JSON like a JSON object, a JSON string, or we can say serializable JSON from the Golang structure that we have. So now let's test this function. This should be fairly quick. So we just do Appwrite run function and select the function namer, and once this is running, we can usually do the curl. So let's do http localhost 3000. So that is how it gives the single list of random name, and if you pass n equal to, it provides two random names, 5, then 5 random names, and so on. So it is able to parse that and generate the response accordingly. So that is just a simple function from scratch that we created. So let's now try to push this function onto the cloud instance of this project, sorry, the function. And you can see that initial function is just the default one, right? Since we didn't configure it from Git or somewhere, we have to do it from the CLI itself. So let's push the namer function to the instance of this project, and once that is deployed on the cloud instance, we should be uh, able to test it on the cloud instance too. So this namer function is now still building. So that has completed the build, and now let's try to test this function. Now it was returning the default response, now it should return the random name. So that is how this is working. Now let's try to do query params n as, let's say, 3. Now this returns the 3 random names from the function. So if you say 100, this will generate 100 such random names. So that is the basic function that we saw from the CLI, right? Now we saw how to deploy it manually from here. Now we have not seen how to deploy a function using manual things, right? So let's connect it later and create a function, start a function. So now there are a few other ways we can deploy the function, which is using the CLI that we saw, right? There are a few things that you can configure over here as well, and if you see, uh, you can download the source code for this function without having CLI intervene with the code. So you can just grab this tar.gz file and gzip file, and then unzip it, and then make changes, and then upload the tar.gzip file again to the console to view the changes. Like, that is not a comfortable way to do it, but it is an option to have. It's a good option to have, so we can do that. So let's create like not let's unzip the file first. So let's copy this function into a starter function, and then unzip the contents of this uh, zip into the current directory. So now we have go.mod, go.sum, main.go, and readme.md into this. So we just delete that zip file and then open this main.go, and we can change and tweak the file as we want. So now let's create one more basic function which will sort of get like uh, basic greet things, right? Provide a if you don't provide anything, it will just say hello world. Or if you provide the name using the query params, you will get hello slash name. So here we have created this function and just paste this new function into this. So this function that we have created is taking the name from the context dot response, so context dot request dot query, and the name. If it exists, then we populate the name as the name, else we pass it to, like, the name will be default as world. So that is that. And once we save this, and we return with the hello slash the name of the name variable name, and then return hello slash world in the text response. However, this function will not be in the CLI registered, like it's not pulled from the changes over there. However, what we can do here is, so this default will be the same templated from the Appwrite template, but we have made changes locally here. But what we can do is we can open here and say we can provide the file. There is tar.gzip file, so we can upload that file. So to create this file, we need to uh, like zip the contents over this directory, which is that we cloned, right, into the starter functions. So if we go into starter functions and list the changes here, and now we need to create this gzip. So dash so tar dash c zf, and this will zip the contents of the file. We need to provide output file, so we'll say uh, so let's call it tar dash xef, and starter function dot tar dot gzip. Sorry, this I messed up. So the actual command is to get the tar dot gzip gz, and the current every content, every file in this current directory I want to zip. So start function dot tar dot gzip will have the zipped version of the source code. And now if we go into I just did that on the folder, so it was not working well. Now I did it correctly, and this should now. So if I go into the uh, folder where I've stored this starter function dot tar dot gzip, I should upload this file, and this should like trigger deployment. This is a manual deployment, by the way, and this will trigger a deployment for that function. So this function will have the changes that we did locally, and then use the gzip version of it on the cloud. Uploaded the gzip version of this function instance. Once this is running, once it has completed deployment, build, it is still building. So once it completes the build, we should be good to see the changes live there. There we go. So this has completed the build and it is active. So this worked out. So now if you see the response for this function, function endpoint is hello world, and now if we provide name as meet, this should be hello meet, and whatever you provide in the name, this should be dynamically configured from the query parameters to the cloud function. So this was another example that we deployed a cloud function using Golang with manual deployment to the console on the Appwrite cloud. So you can try out different things here. John Doe, hello John Doe. So this will work. And now there is one more thing that we can do: create deployment using a Git repository. So let's see how we can do this with Git as well. We have seen CLI, we have seen manual. Now we will see how to do it with Git repositories. So to do that, let's create a Git repository from the CLI. So gh repo create. You can do it from the app itself, but let's do it here. So let's provide a name. I call it image. Sorry, not Appwrite function. Let's not call that Appwrite. Let's call it image decoder. Encoder. Yeah, not Appwrite. Let's not add that, I think. So image encoder, I will take in the image URL and convert it into base64 image, base64 text. So image URL to base64 encoder on Appwrite functions in Golang. So it will be a public repository. I don't know how to get ignore. No licenses. This will create a public repository on GitHub, and I want to clone the repository. So this will clone the repository in the current directory as image encoder. Now it is an empty repository. Now let's go into the GitHub uh, account and see if it has created that repository. It should be empty. Okay, here it is. So this repository is empty. And now let's try to add code and deploy it on Appwrite. So first things we need to do is go mod init. So we need to provide the name of this module. So we can say github.com/method the name username and the repository name. This is a convention, you can give it any name you want. So this will create a go mod file, and now we want to go get sorry let's create a file. Let's first create a main.go file. So we'll first create a main.go file here. So let's copy this from the name of function and let's copy it to main.go, which one is the shorter one, to get the boilerplate code out. So let's go into image encoder and main.go. Now we paste in here, so we have the main boilerplate code running. We don't want to deploy this, we want to do a few things here. So we'll first take in the image URL, which will be either from the get request or the post request. So request dot method, we can have a switch case here. For the get request, we get the URL from the query params. Else, if it is from the post request, we try to get it from the body. So we create a structure called body with the field URL and try to marshal this JSON into Golang specific structure we can use later on. If there's it's not a post or a get request, we just throw out an error that this method is not supported. Else, we do the actual thing, that is to get the image data, read the actual image into a buffer and decode it into a like decode into base64 encoding. So what we do is we send a get request to that image URL, and if it returns a 200 response, then we read the body into a buffer, into a bytes buffer, and then try to convert that into base64 encoding and return that response to the response. So this will be a JSON response. You can give it a binary response as well. We'll see how it works. So let me try to run this. Okay, we cannot run this locally here because again this is from a git deployment and we have not created the function on Appwrite yet. So what we need to do is go mod tidy. We have used the open runtimes and few things is a third-party package. So we need to commit these changes to GitHub repository and link it to Appwrite console. So we add the changes and commit the changes that we have done. But first I need to actually configure this the user. I just do it this way. You can do it however you want. I feel this is more like usable, or is more convenient to do that than to remember the CLI configs for that. Now let's commit the changes and push these changes to GitHub. So git push origin master. This should now have the committed changes on the repository as well. And yeah, this has all the changes that we did here. Okay, so now we can go into Appwrite and create a into the functions. So let's go into functions and create a function. Now we need to sorry, here I don't think so. We can create a function here as well and then link it to the GitHub repository from here, like existing repository. But that's not what I want to do here. I want to like use this GitHub repository as a function, right? So I just log in into this, authenticate Appwrite into this app. And provide access to this repository. So it is image encoder. So once this is done, it should authenticate this Appwrite application into my GitHub repository. Once that is done, we can use this repository to connect to Appwrite Cloud. So you can see it is asking for the branch and the entry point or the root directory. You can provide the functions wherever you have configured your functions, but it is just like normal entry point as main.go, so it should be good enough. Let's name the function as image encoder, and runtime it is go 1.23.3, and entry point is main.go, and that should be, let's give it any permissions. We can give a specific function specific permissions and use JWT tokens, but that is not the scope of this tutorial. Okay, once it is done, it should now like trigger a build on my repository. Okay, it has errored out. Oh, it failed on the deployment. Oh, there is a version conflict here. I think we are using different versions. I am using Go 1.223.3 on my local system, but it is 1.23.1. Okay, so minor changes we need to do here. So I'll just quickly make the changes and get this running. So I did the changes, which is to just update the go.mod file to have the version as go 1.23.1 instead of go 1.23.3. So I think the Go Appwrite's Go runtime is configured for Go 1.23.1 and not 1.23.3. So that changes should be good enough for this. So I just made the changes, and just let's push these changes to GitHub, and this should now again trigger the build. So this is how it works. You don't have to manually hit deployment, like deploy it again. It will continuously deploy however you make changes. So I just changed the version on go.mod, and this should now trigger the build. So once that is triggered, you can see the logs. This should complete the build. Okay, this has completed the build. Then this should be live on Appwrite Cloud instance. So let's check this. Okay, so this has green tick, which means it has successfully deployed the changes. So now let's go into this image encoder cloud function and hit this endpoint. So here, okay, it works, which means it is like showing missing URL query parameter. So let's get this image URL and try to get the base64 encoding of this image. Okay, it's taking us some time. Okay, it didn't respond anything, I think. Okay, let's retry it. Hopefully, hope I am on the right deployment and it has worked correctly. Let's view the execution logs. Okay, here it has not. Okay, that one was the other one, I think. Let's hit this again. Now let's try to run like test it from here. Like hit this cloud and cloud function deployment from local call, not from the browser itself. Might be some issue with that. If we do this, it okay, gateway error, but there seems to be some issue here, but the function is up and running, that is for sure, because it gave URL query parameters as not there, so which means it is hitting that endpoint. It might be some issue with getting the image URL out from the get request that we are sending internally from the function. So let's check this out on, let's say, okay, it's a gateway error. There's something wrong with this. Okay, quick update. So here I just tried it out on a smaller file. It is indeed giving out me the response. If you see, this is a smaller, like like a smaller file, smaller size file. It is a GitHub logo, which is very small image, and I do for the base 64 encoding of it, and it works. So that might be the issue. The response might be too large for it to return. That's why it is doing a gateway error, and this is working. So if you see the data, so now what we responded was base 64 encoding, right? And now if we want to view this like image in, like in a raw view, we can say data colon image slash png, and base 64 is the format of this data that we will be pasting in, and comma base 64 comma. So if it's not visible, can't do much here. uh, let's zoom in. It will zoom that content, not that. So let's say data slash colon image slash png colon base 64, and this, you can see this gives us the image back. So you can see this gives us the back image back, and that is how we are able to convert that image URL into a base 64 encoding, and that later on we can use it anywhere we want if we are actually using it. This was just a dummy API to show what we can do with uh, cloud functions on Appwrite. So we can send, so this response was sent as a binary image, binary response. You can send in raw text as well. So that is it from this video, that what we saw here, right? We saw how we can deploy cloud functions on Appwrite cloud using Golang as the runtime. So we saw how to deploy functions in different ways, using Git, using CLI, using manual deployment of a gzip file. So that is how there are different ways to deploy this functions on Appwrite with Golang. And we also saw how we can use different things on the Golang runtime itself using the open runtimes package that Appwrite is following the convention. And we can also do multiple things that to get storages to access the database on the Appwrite cloud itself. So that is the part for a different video. So that is it for this one. Thank you for watching. We'll be seeing you in the next one.